Six Sigma is a set of techniques and tools for process improvement. It is a quality improvement or problem solving methodology. It was introduced by engineers Bill Smith and Michael J. Harry while working at Motorola in 1986. The goal of the program was to develop Six Sigma quality by improving processes. Other early adopters of Six Sigma include Honeywell and General Electric, where Jack Welch introduced the method in 1995. By the late 1990s, about two-thirds of the Fortune 500 organizations had begun Six Sigma initiatives with the aim of reducing costs and improving quality. Today, almost every major organization in the world is following Six Sigma initiatives and making their processes more controlled and more predictable. According to General Electric, Six Sigma is a disciplined methodology of defining, measuring, analyzing, improving, and controlling the quality in every one of the company's products, processes, and transactions with the ultimate goal of virtually eliminating all defects. Six Sigma seeks to improve the quality of the output of a process by identifying and removing the causes of defects and minimizing variability in manufacturing and business processes. It uses a set of quality management methods, mainly empirical statistical methods, and creates a special infrastructure of people within the organization who are experts in these methods. Each Six Sigma project carried out within an organization follows a defined sequence of steps and has specific value targets. For example, reduce process cycle time, reduce pollution, reduce costs, increase customer satisfaction, and increase profits. The Six Sigma philosophy stems from the belief that statistics and numerical facts can be used to control the quality of manufacturing processes and service organizations. The term Six Sigma originated from terminology associated with statistical modeling of manufacturing processes. It is used in statistical quality control, which evaluates process capability. It refers to the ability of manufacturing processes to produce a very high proportion of output within specification. The maturity of a manufacturing process can be described by a sigma rating indicating its yield or the percentage of defect-free products it creates. A Six Sigma process is one in which 99.99966% of all opportunities to produce some features of a part are statistically expected to be free of defects. That translates to 3.4 defective features per million opportunities. Processes that operate with Six Sigma quality over the short term are assumed to produce long-term defect levels below 3.4 dpmo, that is defects per million opportunities. Motorola set a goal of Six Sigma for all its manufacturing operations, and the goal became a byword for the management and engineering practices used to achieve it. Organizations need to determine an appropriate Sigma level for each of their most important processes and strive to achieve these. As a result of this goal, it is incumbent on management of the organization to prioritize areas of improvement. Six Sigma doctrine asserts continuous efforts to achieve stable and predictable process results, for example, by reducing process variation, are of vital importance to business success. Manufacturing and business processes have characteristics that can be defined, measured, analyzed, improved, and controlled. Achieving sustained quality improvement requires commitment from the entire organization, particularly from the top level management. Features that set Six Sigma apart from previous quality improvement initiatives include a clear focus on achieving measurable and quantifiable financial returns from any Six Sigma project, an increased emphasis on strong and passionate management leadership and support, a clear commitment to making decisions on the basis of verifiable data and statistical methods rather than assumptions and guesswork. Six Sigma projects follow A project methodology inspired by Deming's plan, do, check, act cycle. This five-phase approach called DMAIC is used for problem solving. We begin in the define phase by defining the problem and the project goals specifically. We also define the customer requirements in this phase. Six Sigma processes are completely driven from the point of view of the customer. They start by identifying what is important to the customer, that is the critical to quality metrics. Then, in the second phase, we measure key aspects of the current process through observation and data collection, gain a thorough understanding. Then we analyze the data in the third phase to investigate and verify cause and effect relationships. We try to understand the root cause or causes of the problem. We sometimes call these the critical X's and Y's. For example, Y could be the defect rate, and the X's are the inputs, those things that affect the output. We try to seek out the root cause of the defect under investigation. Once we determine the key factors or root causes, we develop and select solutions in the improve phase. We improve or optimize the current process based upon data analysis by using techniques such as design of experiments and standard work to create a new future state process. We set up pilot runs to establish process capability. Finally, in the control phase, we develop a plan for process management going forward. We control the future state process to ensure that any deviations from the target are corrected before they result in defects. We implement control systems such as statistical process control, production boards, visual workplaces, and continuously monitor the process. Things like control plans, process dashboards, or statistical process control are used. This process is repeated until the desired quality level is obtained. Some organizations add a recognized step at the beginning of these five steps, which is to recognize the right problem to work on, thus yielding our DMAIC methodology. Formal Six Sigma programs adopt a kind of elite ranking terminology similar to some martial arts systems like judo to define a hierarchy and special career path that includes all business functions and levels. You become certified by completing training, executing projects, and by passing an exam. Executive leadership includes the CEO and the other members of top management. They are responsible for setting up a vision for Six Sigma implementation. They also empower the other role holders with the freedom and resources to explore new ideas for breakthrough improvements by transcending departmental barriers and overcoming inherent resistance to change. Champions take responsibility for Six Sigma implementation across the organization in an integrated manner. The executive leadership draws them from upper management. Champions also act as mentors to black belts. Master black belts, identified by champions, act as in house coaches on Six Sigma. They devote 100% of their time to Six Sigma. They assist champions and guide black belts and green belts. Apart from statistical tasks, they spend their time on ensuring consistent application of Six Sigma across various functions and departments. Black belts operate under master black belts to apply Six Sigma methodology to specific projects. They devote 100% of their valued time to Six Sigma. They primarily focus on Six Sigma project execution and special leadership with special tasks, whereas champions and master black belts focus on identifying projects or functions for Six Sigma. Green belts are the employees who take up Six Sigma implementation along with their other job responsibilities, operating under the guidance of black belts. Six Sigma enables companies to improve the marketing's strategic, tactical, and operational processes as a way to enhance the top line to drive revenue. By applying Six Sigma to marketing, you can develop a lean, efficient marketing workflow, identify leading indicators of growth, and become proactive about performance improvement. Measurement of performance is one of the five fundamental phases in the Six Sigma methodology. Once you begin measuring marketing performance, you can begin to make modifications and improvements. Six Sigma provides both a methodology for process improvement and a way to prove its value. These additions are above and beyond the traditional Six Sigma approach to cost reduction.